Welcome to the lesson video on k-means clustering. So we're going to talk about k-means clustering. So first we want to talk about clustering. Clustering is a process of grouping points in our data set by some measure of similarity. So it's similar to classification, but in classification you're pre-assigned the class labels and you're trying to match those class labels on your data using some algorithm. In clustering, we're not giving class labels. We just want to assign our data points into some groups based on some sort of similarity between the data points. So each pair of data points in each group should be similar to each other, and the data points in different groups should be different from each other. So that's the basic goal in clustering. K-means clustering is a specific type of clustering. And in k-means clustering, k represents the preset number of clusters. So that has to be chosen before running the algorithm. And each point in the k-means clustering is clustered by its distance to the cluster means. So we'll talk about that, really what that means and how that works in a little bit. Why would we do clustering, or k-means clustering in particular? Well, it just gives us a quick look at the natural grouping among the data points. Let's walk through an example of k-means clustering. So this shown on the right is a plot of our data we're going to walk through. And in this example, we're going to choose k equal to 3. So that means we're going to do 3 clusters. And so here's the algorithm on the screen, and here's step 1 of the algorithm. So what we've done so far is this step right here. So we randomly assign a number to each data point from 1 through k. And then those are the initial assignments for the observation. So in this picture, we don't have numbers, we have colors. So for example, there's a data point there, and it's been randomly assigned the color gold. And we have 3 classes, a gold class, green, and purple. And so every data point just randomly gets assigned some color, some class assignment. Then we iterate, starting in on step 2, we're going to iterate these 2 processes, and these are going to modify those assignments to all our observations until we hit an equilibrium, meaning repeating these processes don't modify them anymore. And so this is iteration 1, step 2a. So we're doing this step right here. So for each class, or for each cluster, we compute the mean of that cluster, being the centroid. And so for example, here we have the orange centroid, so that's the mean of all the points that are orange. Down here, we have the purple mean, and here we have the green mean. Typically, because everything was randomly assigned from the beginning, these means will be pretty close to us. The next step, let's think about the next step now before we step forward into it, so we can see what we would expect. Step 2b, assign each observation to the cluster whose centroid is closest to it. So let's think about the orange centroid, right, showed in this large circle. It's the mean of all the initial orange points. And pick this data point right here. It's closest to the orange, so that's going to be assigned orange next iteration. This observation, this data point, is also closest to the orange. In fact, everything up here in that general area is going to be orange, or specifically maybe something like that. So this area should be assigned orange. The purple will get everything in this area because all the observations approximately in that area are closest to the purple, and the green should get assigned generally everything out here. So let's go to the next step and see what happens and see how close I was with my little sketch. Yeah, I was pretty close. So everything here got assigned green, everything there got assigned purple, and everything up top got assigned gold. And so we are in step 2b. And now we're going to do 2a again. And let's think about what happens when 2a, we have to recompute these cluster centroids. The centroid is the mean of the cluster. So the mean of all the green points, maybe it'll be right there. The mean of all the purple points, I'm not sure. Maybe it'll be right there. And the mean of the gold will be right there. Now, once we've computed these new means, let's see where they are. I was pretty close with my little sketch. That's 2a. This is our second time being at 2a. Remember, we're going to iterate through these till we get no more changes. And then we're going to do 2b in a minute. So let's think about what might change. Maybe there's a couple of points right here. We look at what centroid they're closest to. They're closest to the green, I think. So next iteration, those couple will be green. So we'll see some colors shift on the next iteration. So let's go to the next iteration and watch. You can watch the ones that I picked out, and we'll see those change a little bit. And then we recomputed our centroids, and then this is our final result. If we were to run through step 2 again, another iteration, nothing would move, and you could see our clustering is based approximately on this. Now, if you think about the, distances and the way things are computed, the separation between your classes is always going to be linear, right? That's just a consequence of the definition, and we're assigning by distance to the centroids or to the cluster means. Here is all the steps on the same slide. You can see how we randomly assigned, then we computed the means and then randomly assigned data. Then we recomputed the assignments based on those means. Then we computed the new means, and we iterate until we get to this, which I think is just maybe one more step, which is our final result. Here's k-means clustering using 6 different initial cluster assignments. Remember that first initial step, things are just randomly assigned. You don't always wind up at the same final result. And so that final result you end at, it's not a deterministic process because we have that random assignment in that first step. And so that can lead to different final results. Above each of these is written this objective function, the value of this objective function. Let's think about this a little bit. So this function here, there's a sum, this outer sum, and it's a sum over this formula for every class. And so this is 1 over the number of points in the class, and this is the sum over the squared distance between each pairs of points. So this is some measure of how spread out the classes are. And so smaller is better, and we can see in red 235.8. 4 of these 6 times we get 235.8. Basically the same assignment. The colors may vary which class gets which color, but basically the same clustering. And then there's 2 where we didn't get what seems to be maybe an optimal clustering, an optimal value for this objective function. So going through the k-means clustering process will reduce that objective function, but it might not always wind up at the minimum. So we're not guaranteed to hit the best possible clustering. So review for k-means clustering. What is it? Clustering is a process of assigning groups of the data by some measure of similarity within the groups. K-means clustering is a specific type of clustering in which k is a preset number of clusters set by the user, and each point is clustered based on its distance to the cluster means. And as we showed, we iterate by computing the means and then computing the new cluster assignments, and then based on those assignments, compute new means, and we iterate on that process until we get no more change on our iterations, or until some number. There's other stopping criteria that you could use, of course. We could limit to 10 iterations, or we could limit to some runtime, or we could limit to, we're going to run it until we get less than 3% change. With large data sets, k-means clustering can take a long time, so there's other ways to set our stopping criteria by, instead of running till we get no more change. So why do we do this? It gives us some measure of natural groupings among the data points. Some other things we talked about. The user has to determine k. So you have to know how many clusters you're going to pick. So what you pick as k may not be the natural optimal value for k for your data, but you get some measure of clustering. And another property we've talked about for k-means, the separation between groups is always linear. Thank you for watching.